All right, so let's begin. Yesterday we ended up on question number 3 where it says find the arc length. Again, not that difficult. The formula for arc length is simply the radius times the angle. The only thing to be aware of is that the angle needs to be in radians, right? That's it. Not that difficult of a question if you know how to convert between radians and degrees. Question number 4, it says find the exact values. Are these in degrees or radians?
They're in radians
How do you know?
because of the pi.
Yeah, because of the pi. So if you were to plug these in on your calculator, right, would you get the exact answer? Now that's a tricky question. It depends on the calculator. Mine, if I plug it in, it'll give me the exact answer. Because it can do like fractions, but I don't know the one that you have that you have the TI calculator. I don't think yours does fractions. But anyways, if this question comes up, you won't be able to use a proper calculator to answer this. So this has to be done by hand. Whenever you see the word exact in trig, you know it's trig because of the SOHCAHTOA ratios there. Know that it's a hand question. It's by hand manual question. So, okay, so calculator is not that useful. So how do we even start? It all depends on the special triangle. There are two special triangles. One of them is 30, 60. 30 is pi over 6 radians. And then you have 60, which is going to be pi over 3 radians. That's 60 degrees. This is one triangle. What's the other triangle?
The 45, 45.
Exactly. The other one is 45, 45, which is not going to come into play for this question. I know that because all the angles are in terms of threes and sixes. So I think we're going to be using the first triangle, but I'm just going to draw it out. So for the 45, 45, 45 is pi over 4 in radians. 45, which is pi over 4. So these are your two triangles. And the way you remember this, 45, 45, I think is easy because they're exactly 1 units. And because the angles are the same, it's an isosceles triangle. That means the side lengths are also going to be same. So you have one here, use Pythagoras theorem, you're going to get root 2 for the hypotenuse. For the 30-60 triangle, it's not as simple, but this is the trick. Sine 30 is 1 over 2. And you know sine as a ratio is opposite divided by the hypotenuse, right? SOHCAHTOA, so opposite over hypotenuse is sine. So the thing you need to remember for the 30-60 is that sine 30 is 1 over 2. How does that help you? Relative to 30 degrees, relative to pi over 6, the opposite will be 1 unit. So here we'll have 1 unit, and the hypotenuse of this triangle is going to be 2 units. What's the missing side? If you have 2 as the hypotenuse, 1 as the base, what's the adjacent side length? Is it just 1? How do you find it? Just use Pythagoras, right? It's not that difficult. Just use Pythagoras to find the missing side length. Here, I'll do it. So, you know, Pythagoras' theorem says c squared equals a squared plus b squared. In a triangle, a and b, the position doesn't matter. You can say this is b, this is a. A and b, you can replace them. But hypotenuse, it will always be c. And hypotenuse is always the side that's opposite to the 90 degrees. So then you have 2 squared equals a squared, which is missing, plus b squared, which is 1 squared. So a will be root 3. So that missing side length there is going to be root 3. So you can just use Pythagoras to find that. Not that difficult. So we're going to put a root 3 here. All right. Now let's start answering the questions. Tan pi over 3. Remember, we're just doing SOHCAHTOA. The only difference is now we're in radians. What's tan pi over 3? It'll be something over something. No? Pi over 3 is here, right? Pi over
Mm-hmm.
3. We're looking for tan, which is going to be the opposite over the adjacent. So this is our reference angle. The opposite is root 3, right?
Mm-hmm.
Divided by the adjacent is 1. So tan pi over 3 is simply root 3 done. So that question, not that difficult. Sine of 7 pi over 6. This one is slightly more difficult. Which quadrant are we in? 7 pi over 6.
I'm sorry, I'm so confused. I don't know why.
Yeah, don't worry about it. Don't worry. It's all good. So the question was, which quadrant is 7 pi over 6 in? Okay, so let's draw them out. So 0 is here, 90 is here, 180 is here, 270 is here, and 0 is the same thing as 360. These are in degrees, right? This is very simple stuff. This is just
Mm-hmm.
a Cartesian plane. Now in radians, the only thing that's going to change is that 0 is still 0. Okay, now these are the angles in radians. 0 is 0, 360 is 2 pi. 90 becomes pi over 2. 180 is pi, right? That's our conversion factor. Pi
Mm-hmm.
radians is 180 degrees. That's where it comes from. So 180 is literally pi. 270 is 1.5 pi. We write it as 3 over 2 pi, or 3 pi over 2. Now the question was, which quadrant is 7 pi over 6 in? Now 7 pi over 6 is slightly more, right? Now you want to think about these in terms of pies. Is this more than 1 pi or less than 1 pi? 7
More.
over 6. It's more, right? So it's more. Pi is right here. This is about 1.1 pi. So we're going to be in quadrant 3. We're going to be right here. This big distance is going to be 7 pi over 6. That's called your principal angle. What you're interested here is to find the related acute angle. Anytime the angle is more than 90 degrees, anytime you have an obtuse angle, you want to be using the related acute angles. And the related acute angles, they're always from the horizontal. What that means for us is that this way is not the acute angle. Acute angle is always going to be from the x-axis, from the horizontal. So this way, this way. What is this going to be? The big thing is 7 pi over 6, okay? Up until here is pi, okay? Up until here is pi. We're just interested in this chunk. So the related acute angle is simply going to be 7 pi over 6 minus pi over 6. Here's another way to understand this. 7 pi over 6 is 210 degrees. How did I get this? I simply replaced pi with 180. That's the conversion factor. This is something that we did yesterday, so you can go back to that video if you're not sure. So 7 pi over 6 is 210 degrees, which is in quadrant 3, right?
Mm-hmm.
This is 180. This is 210. What is going to be a related acute angle? This angle.
It'll be 30.
It'll be 30. So same principle here. But instead of doing 210 minus 180, here we're going to do 7 pi over 6 minus pi. 7 pi over 6 minus pi. And you will see that when you take the LCDs, that becomes pi over 6. LCDs is a 6. So you multiply by this by 6 on the top and the bottom, you get pi over 6. So your related acute angle is 30 degrees or pi over 6. So that's the first thing you do when you have an angle more than 90 degrees. So now we go back here. Sine 7 pi over 6 is the exact same thing as sine pi over 6. The principal angle, the ratio, whatever you have, sine, cos, tan, doesn't matter. Sine cos tan of the principal angle is going to be the same thing as sine cos tan of the related acute angle. So sine 7 pi over 6 is going to be exactly sine pi over 6. It's because it's periodic and it's symmetrical. That's where it comes from. But there is one key difference. And the key difference comes from the CAS rule. The only difference between these two, principal angle and the related acute angle, is that the sine of the related acute angle can either be positive or negative, depending on the CAS rule. So what's the CAS rule? It just says which quadrant is positive for which ratio. In the fourth quadrant, only cosine is positive. In the first quadrant, all is positive. In the second quadrant, sine. In the third quadrant, tan. So we're in the third quadrant. Is sine positive or negative in the third quadrant?
Negative.
Negative. So sine 7 pi over 6 is going to be negative sine pi over 6. If
Mm-hmm.
this was a tan, then it would not be negative because tan is still positive in quadrant 3. But because it's sine, we have to put a minus sign. From this triangle, what's sine pi over 6? What's the ratio for sine pi over 6? It's just opposite over hypotenuse. It's not a trick question.
1/2.
1 over 2 is right. But now you just put a minus sign. And that's it. That's the final answer, and you're done. So for these angles bigger than 90 degrees, you first want to figure out which quadrant you're in, and then you want to draw the special triangles, and the last step, you just put a plus or a minus sign. You'll see, well, once you get it, it's not super difficult. It's just 3 steps. The most important step, again, you have to identify which quadrant it's in. So forget about the secant. 5 pi over 3. Again, I can draw it for you. 5 pi over 3. Which quadrant is it in?
The fourth one.
The fourth one, exactly. So it's here. This is going to be your principal angle. 5 pi over 3. How do we find the acute angle? The acute angle, again, will be from the horizontal. It's not going to be this. It's never from the vertical line. It's always from the x-axis. So your acute angle is going to be this. How do we find that? If it makes your life easier, okay, what we're going to do is we're going to convert these into degrees just to make our life easier. To convert these into degrees, simply replace that pi by 180. That's the conversion factor. So 5 times 180 divided by 3, it's 300 degrees. So this 5 pi over 3 is equivalent of 300 degrees. What would be this? What would be the acute angle if the principal angle was 300 degrees? Remember, there's 360 degrees in a circle.
It'll be 60.
It'll be 60. So you did 360 minus 300. Same idea here. You're going to be doing 2 pi, right? Going to
Mm-hmm.
be doing, or if you know 60 degrees is pi over 3, you already know your acute angle. If you don't, 2 pi minus 5 pi over 3, like that. Again, you're just doing 360 minus 300. Take the LCD, which in this case will be 3. So I'm going to multiply this by a 3 on the top and multiply it by a 3 on the bottom. You'll get 6 pi minus 5 pi over 3. Pi over 3 is a related acute angle. So sine 5 pi over 3 is the exact same thing as sine pi over 3. Positive or negative in quadrant 4?
Negative.
Negative. From the triangle, what's the value of sine pi over 3? So pi over 3 is here, 60 degrees. What's the ratio
It'll
of
be
sine?
3/2.
Yeah, root 3 over 2. The only one last step is that it's negative, and you're done. Final answer. Again, it's a 2-step answer if you know this stuff. Which again, you just think of it in terms of degrees, because radians again is a new concept. It's a grade 12 concept, but in grade 12 is all radians. I don't think you'll see a lot of degrees. Degrees was grade 11. Let's try this next question. And all these questions are just algebra. They're not very difficult. What is tricky is something like this, where it says prove the trig identity. These are definitely the hardest part about trig. And maybe 3D problems, where you have to use the sine law and the cosine law, sometimes both of them multiple times. That's the hardest thing about trig. These things are just pure algebra. Most of it is just SOHCAHTOA. So let's see if we can figure this out. Express the lengths A and B in the figure in terms of theta. So it's not asking us to actually find out how long these are. That would not be possible. You need to know at least two things in a triangle, in a right angle triangle. You know the hypotenuse, but you don't know any of the other angles, or if you also don't know any of the other sides. So this triangle, as it is right now, is unsolvable. You need two items known. Well, you know one thing here. So the best we can do is express these things in terms of theta. I don't think it's terribly difficult. So let's look at A, right? A. This is your reference angle. We can't write A in terms of B. If you look at the question, it says express the lengths A and B in terms of theta. So you can't have like a B term in your A term. You're not allowed to have this. What that means is that when we're trying to figure out, do I use sine, cosine, or tan here? You want to use the one that doesn't use the other letter. So that means for A, you can use this angle and you can use the hypotenuse. That means this is the opposite and this is the hypotenuse. So which ratio would work here? There's only one ratio that's going to work.
Sine.
Sine. So you have sine theta is equals to A over 24. Therefore, A is 24 times sine theta. Done. Let's look at B. What about B? It's the same concept. Is it going to be sine, cos, or tan? This is your reference angle. You need to use this side. You cannot use this. That means you're left with this. That's sine, cos, or tan?
Cosine.
Cosine. So cosine theta is going to be B over 24. So B is going to be 24 times cosine theta, and that's the final answer. Again, not that difficult, right?
Mm-hmm.
Just a straight up SOHCAHTOA problem. Tricky thing here is that you need to know you can't write one in terms of the other. So if you use tan, you're gonna get a 0. Let's see what's easy here. Kind of want to do this, kind of don't want to do this. Let's do it. So they've given us a ratio, sine of x. This is a difficult problem, so I'll tell you that. This one's difficult. It's not going to be a one step. So they've given us sine x is 1/3. So we know it's not from the special triangle. So if you try to arc sine this or sine inverse this, you're going to get an answer with a bunch of decimals. So we know two ratios. We know sine x, we know sec y. Remember this, a ratio is simply a triangle. Is a triangle. So they've given us one triangle here, and they've given us one triangle here. So we have in total, we have two triangles. Where x and y lie between 0 and pi over 2. Now that is critical information. They're telling you which quadrant our triangles are in. This is the clue. Which quadrant are we in between 0 and pi over 2? The angle is between 0 and pi over 2. Which
The
quadrant?
first one.
The first one. So should we be getting any negative values in the first quadrant?
No.
No, right? No. So here's what I'm going to do here. I'm going to make two triangles in the first quadrant. Sine of x. So let's make this to scale. Why not? Sine x is 1 over 3. And you know sine as a ratio is opposite over the hypotenuse, yeah?
Mm-hmm.
No, no, this is not going to be as precise as I thought because hypotenuse is 3 units. And if I do something like this, right? If I go 3 boxes long, this is more than 3 units. It's not 3 units. It's because this is 1 unit, this is 1 unit. That means that's going to be 2 units. What I'm trying to say is that I can't draw the hypotenuse to scale. So what I'm going to do is I'm just going to draw a triangle. So boom, boom. Let's just draw this triangle. Let's put X here. And we know this triangle, the opposite from X is 1 unit. So this is going to be 1 unit. And the hypotenuse of this triangle is going to be what?
3.
3. So that's in the first quadrant. Should I draw it on the same plane? Might get too busy. I'm going to draw it on another plane. So for the other triangle, we're just going to draw it on another plane. It's the same kind of concept. The sec y is 5 over 4. So again, remember, so, ka, toa. Secant, what is that the reciprocal of? Sine, cosine, or tangent?
Cosine.
Cosine. So if cosine is adjacent over hypotenuse, what is secant?
Hypotenuse over adjacent.
Perfect. So we know we have another triangle in quadrant 1. We're going to put a y here. And then the hypotenuse of this triangle, again, you need to know where everything is. The hypotenuse of this triangle is 5 units. And the adjacent from your reference angle, remember, I put my y here. The adjacent is 4 units, like that. Now using Pythagoras theorem, you can easily come up with the remaining two sides, okay?
Mm-hmm.
If you want the maths, that's gonna be 9 minus 1, that's gonna be root 8. Again, just Pythagoras theorem. B is the square root of c squared minus a squared. Same thing here. A is the square root of c squared minus b squared. So it'll be 25 minus 16. It'll be root 9. It's going to be 3. 3, 4, 5 is a Pythagorean triple, right? 3, 4, 5.
Mm-hmm.
That's not going to be the case if 5 is one of the other side lengths, though, so don't get confused. If you see 4 here, if you see 5 here, this is not going to be 3. That's the only time it's not going to be a 3, because the hypotenuse is the longest side, so it has to be bigger than 5 in this triangle. So there are our two triangles. Cool. So now, what do they want us to find? Evaluate sine x plus y. Again, you'll see this in grade 12. Sine x plus y. This means, this refers to, you'll notice that there's two angles in there, right? And you're adding them. When you're adding or subtracting two angles inside a ratio, we haven't seen this yet. Maybe we have actually a while ago. This is called a compound angle formula. So there's one for plus, there's one for minus, and there's one for, well, it depends on sine, cos, tan. All of them have their own formulas for plus, and then there's one for minus. They're very, very similar. So let me give you the formula for plus. And in the beginning, you'll be given these, I would assume, in your tests and stuff. So sine x plus y is equals to sine x times cosine y plus cosine x times sine y. So it's made up of 4 terms. And they alternate. It's sine x cosine y and then cosine x sine y. So let's see what we can get from the triangle. What's sine of x? Well, that's given in the question actually. Sine of x is 1 over 3. So we know that this is 1 over 3. If secant of y is 5 over 4, what's cosine of y?
4 over 5.
4 over 5. So we have both of these terms that was given in the question. Plus cosine of x. So let's look at this triangle. What's cosine of x?
Root of 8 over 3.
Yes. Now let's look at the other triangle. What's sine of y?
3 over 5.
3 over 5. And now we're going to clean this up, and that's it. So the hard thing about this question is that you need to know whenever they give you a ratio, you know everything in a triangle. If they give you something like this, you can complete everything in this triangle. You know all three side lengths. Well, there's a 90 degree, and you can also figure these out. You can complete a triangle if they give you a ratio. Now for the last step, we're just going to clean it up. 4 times 1 is a 4. 5 times 3 is a 15. Plus 3 times root 8 is 3 root 8. 5 times 3 is a 15. So for the final answer, you can write it like this, or if you want, root 8 is 2 root 2. You can write this as 6 root 2 over 15. And that's going to be your final answer. Cool?
Hmm.
So again, a difficult problem because you need to know things like the compound angle. But yeah, as you can see, right, once you know, it's not terribly difficult. Again, the hardest parts are definitely, in my opinion, is going to be something like this, proving trig identity. Because questions like these, the one that we just did, there's really only one way you solve it, by finishing the triangle. But a trig identity question, you can approach this using many, many, many ways, which makes it much more difficult. So let's look at this one. Here's the golden unwritten rule. Maybe I'll write it down. Trig identities, you're always going to start on the harder looking side. Always start on the more complicated looking side, because that will give you more things to work with. What that means for us for this question is that we're not going to be starting on the right side, okay?
Hmm.
Because we could start sec theta, and then that becomes 1 over cosine theta. And then where do you go from there? How do I go from this to this? That makes it a little bit more difficult. In this case, I'll tell you how you could go from here to here. You're going to have to multiply and divide by the same thing. It's not a conjugate in this case. We're not rationalizing anything, but the concept is the same. Because right now I'm lacking, see over here, you have two distinct terms with a plus sign. Right now I only have one term. So the only way I can get two distinct terms with a plus sign in the middle is if I multiply it with something that has a plus sign in the middle. I don't know exactly what this term is yet, but once I solve it from the other side, I'll tell you exactly what this is. So let's go on the left side. That's why it's always easier to start on the left side, on the harder looking side, which in this case is the left side. And then here are some ratios that you need to know. Tan, okay, tan is sine over cosine. This you have to know. Next thing you have to know is something called Pythagorean identity. It's just a fancy way of saying that sine squared plus cosine squared is always going to be 1. So these are the two things you need to know. Maybe the third thing is going to be you need to know that secant is 1 over cosine. You need to know how the secondary ratios relate to the primary ratios. That's pretty much it, I think, for these questions. Later on, it gets more difficult, but let's see this. So what's the only thing we can do here? There's only one thing we can do from here. Cosine, you can't simplify or rewrite this. Sine, you can't simplify or rewrite this. What about tan?
You can change it to sine over cosine.
Exactly. So that's the only thing we can do. So that's what we're going to be doing. Tan is sine theta over cos theta times sine theta plus cosine theta. Yeah?
Hmm.
Sine times sine is sine squared. So this is what we have so far, right?
Hmm.
Now there's only one thing we can do. There's a fraction here. This one, there's no fraction. So what's the only thing we can do here if I'm going to combine the fractions?
Common denominator.
Common denominator. So you have to multiply this by cosine on the top, and then you have to multiply it by cosine on the bottom. So you get sine squared theta plus cosine squared theta divided by cos theta. What's sine squared plus cosine squared? It's the Pythagorean identity, number 2 there. 1.
It's 1.
So this entire thing is a 1, and then you're left with 1 over cosine theta, which we know is secant theta, right? And there you go.
Mhm.
That's the answer to this question. That's if you started on the left side, which is always advisable. Now, let's say you're feeling brave. You want to start on the right side. Okay, sec theta. I know sec theta is 1 over cosine theta, but now I need to multiply this with something. And turns out what you multiply this is you multiply with sine squared plus cosine squared on the top and sine squared plus cosine squared on the bottom. Okay?
Mhm.
Or that's one way. Or you can just replace the 1. Both of these will work. You can just replace this 1 with sine squared plus cosine squared. And then you work backwards this way. So you split it apart over cosine theta plus cos squared theta over cosine theta like that. Here this cancels out with this, so you're left with cos theta. Here what you're going to do is you're going to split up the sine squared into sine theta over cosine theta times sine theta. Now you have tan times sine plus cosine, which is what the question was to start off with. So again, the right side start is not really recommended. Left side start is very simple. Let's try another one. I don't know if I can actually do this one. We're going to skip this one because this one requires something called a double angle formula. There's 2x here, right? Sine. Now you'll notice that the 2 is inside the function. This is called a double angle. And there's multiple formulas for these. Let's not get into it. There's at least 6 formulas. Um, so this was called compound angle. This is you're going to be doing this in grade 12, compound angle. And then there's something called double angle. You know what? I'll just show this to you. So we're going to build on the things from the last question. What you need to know for this question is that sine 2x, okay? Why is my thing not writing? Sine 2x, this is the only new information, is 2 sine theta cos theta. All right, so which side looks more difficult here? Left side or right side?
The left side.
The left side. So let's start on the left side. What's the only thing we can do on the left side? They've given us tan, so that's a hint. Remember, tan, you can write it as something else. So what's the only thing we could possibly do on the left side here?
Rewrite tan.
Yeah, rewrite tan. That's the only thing we can do. So tan, we know, is sine over cosine, right?
Mhm.
So we're going to do this on the top, and then we're also going to do this on the bottom. Now you have fractions, and then you don't have fractions. You know you're going to be combining. So on the top, nothing changes. But in the denominator, I'm going to skip a step here. You know how to do LCDs, right?
Mhm.
Like that. Boom. Are we good so far?
Yeah.
So far, nothing too complicated. We just rewrote tan as sine over cos, and we took the LCD. Now let's see what we can do. There's 4 levels here, right? Does the bottom level go all the way to the top, or does it go to level 2? Maybe this will help. If you're ever confused in a thing like this, right? Because there's 4 levels. If you're ever confused, just write it out. This is what I always do if I'm confused about these things. So I have A over B, that's the top 2 levels, and then I'm dividing A over B by C over D, which is the bottom 2 levels. Anytime there's a division sign dealing with fractions, you're going to change it into a multiplication and flip it upside down, like that. So does the D level go all the way to the top or does it go to level 2?
It goes to the top.
It goes to the top. So now let's clean this up even more. And you'll see that the answer is just going to come, I think. So you have 2 sine theta times cosine squared theta. So divided by cos theta, and you know that the level 3 will go to level 2. I'm going to skip a step again here. This level 3 cosine squared plus sine squared. Can we rewrite this as something else?
As one.
As 1, right? So, and then 1 goes to this level here. So that means nothing changes, okay?
Mm-hmm.
So cos squared theta over 1. 1 goes to that level, like this. So now let's see if anything cancels out. Does anything cancel out? Yes. Cos theta with one of the squares. Yeah? It's like canceling out
Mm-hmm.
a squared and a with the squared value. So now let's see what we're left with. We're simply left with 2 sine theta cosine theta, which we know is sine 2 theta or 2x, whatever the angle is. Sorry, the 2 needs to be inside the function. Sine 2 theta. There we go. And that's the answer to this problem. Okay, it was supposed to be x. I wrote theta, but nothing really changes. Did that make sense?
It did.
So again, these questions, you just have to like kind of play around with them. You'll see that sometimes there's only one thing you could possibly do. Like the only thing we could have done here is replace the tan as sine over cos. Now that's one thing you could have done. Now there's another approach you can use. This ratio, 1 plus tan squared, is actually secant squared. This is one of the other lesser known Pythagorean, what did I call it? Identity. So there's another one here. So you can replace the denominator with secant squared and try it out. See if you get the same answer. Let's move on. Let's move on from all of this. Let's move away from trig. Let's look at this one. So these are nothing to do with trig. It's just functions. So your origin is in the middle. Let me just make it a little bit thicker. So the right there is your origin. Part A says estimate the value of f2. It's a very simple question. What's f2 approximately? You don't have to be precise. What is it asking us?
F2 is around 3.
Yeah, done. B, find the value of x such that f of x is positive 3. So which x values give you a y value of positive 3 is the question.
2.
Is there any more? What about like 5.5? That does it as well, right?
Mm-hmm.
So 3 is here. So that point on the x, which is about 2, and this point on the x, which is about 5.5. So there's 2 answers there. Okay, C, state the domain of f. So let's say it stops here. I don't know. I think it's going to be XCR. It looks like a sine function. But let's say it stops right there. 2, 3, 4, 5, 6. Negative 6 to 6. So the domain is going to be negative infinity. Well, negative 6 to 6, right?
Mm-hmm.
Similarly, the range is going to be from negative 4 to 4. It's just the possible y values your function can take. Alrighty. Party, on what interval is f increasing? We're strictly looking for increase. Where is the function growing, basically?
When x is between -4 and 4.
Perfect, yes. And at exactly -4 and at exactly +4, the slope is 0. So it's neither
Mhm.
increasing nor decreasing at those exact points. That's why I'm using a rounded bracket here. I'm not using the inclusive bracket because at exactly 4, the function has a slope of 0. So it's neither increasing nor decreasing. F is F 1-to-1. What's a 1-to-1? 1-to-1 is something like this. A function where you have your x values and you have your y values. So for every x value, it corresponds to one y value like this. This is called a 1-to-1 function. So for each unique x value, there's a unique y value. Is that the case for this question? It kind of brings us back to question B. This will help us answer it. So for the y value of 3, we had two different x values, approximately 2 and approximately 5.5, right?
Mhm.
So what this means is for an x value of 2 as well as 5.5, you have the same y value. So is that 1-to-1?
No.
No, it's not. No, because you have multiple x values for the same y value, therefore it is not 1-to-1. Part G, is the function odd, even, or neither? Now remember, odd functions are reflected about the origin. This is an example of an odd function. An even function is something like this, where it kind of is symmetrical. So even function is whatever you have to the left of the origin, you have the exact same thing to the right of the origin. An odd function is whatever you have in quadrant 1, you have in quadrant 3, or vice versa. You could also have something like quadrant 2 and 4, something like that as well. So is this function odd, even, or is it neither? What do you think?
Odd.
It's odd. If they ask you to prove it, what you can do is here's the formula for odd, okay? To prove it, what you have to show is that f of minus x is negative f of x. Here's what I mean. So let's find f of what? -4. What's f of -4? It's -4, right?
Mhm.
The x value at -4 is -4. So now notice how, okay, actually that didn't help. You need to do one more thing. What about f of +4? What's f of +4?
It's 4.
It's 4. Now look at this symmetry. F of -4 is -4. F of +4 is +4. Therefore, this condition is satisfied. Whatever you have down here, you have the same things up here. So therefore, it's an odd function, and that's the answer to this question. Again, not terribly difficult. Okay, now let's talk about this. What does this symbol imply? Is that the reciprocal? What does that symbol even mean? The -1 there. It means inverse, okay? Inverse,
Mhm.
not the reciprocal. It means inverse here. So anything f inverse. It's the, remember what is an inverse? Remember what it is? What's an inverse function?
isn't it just like the opposite?
What does the opposite mean? Like upside down?
Like when you undo something?
When you undo something? Okay, that's one way of looking at it. So inverse is when the x becomes y and y becomes x, okay? So xy essentially becomes yx. The points are swapped, okay?
Mm-hmm.
Points are swapped. So this is with respect to a function. With respect to a function, the points are going to be swapped. It does undo something if you do something like this. Look at this. If you take the original function, and if you pair it with the inverse function, then these two cancel out in any order. The order doesn't matter as long as both of them are in there. So the answer to both of these questions will simply be an x, whatever's on the inside. But this is not that kind of a question, right? We're just talking about graphing inverse functions. So from that perspective, points are swapped. That's all you need to know. So let's go one by one. I'll help you. Part A, state the value of G2. I think that's a simple question. It's just asking you the y value when the x value is 2, right? So it looks like it's a 3. Do you agree?
Mm-hmm.
It's about a 3. Maybe we label these here. So 2, 2, 3, 2, 3. -1, -1. All right, so the answer to this is 3. B, why is G 1 to 1? Remember what 1 to 1 is? Unique x for unique y. Now, why is it 1 to 1 here? Well, because there's no multiple points, right? There's no repeating points for the same unique point. If you wanted to, you could even like graph it out, x, y. So -1, it's like negative 0.5. At 0, it's a 1. At 1, it's like 2.5. At 2, it's a 3. At 3, it's 3.5. You'll see that all the points are unique, right? -1 only goes to negative 0.5. 0 only goes to 1. 1 only goes to this. This only goes to this. There's no repeating points. You see?
Mm-hmm.
That's why it is 1 to 1. Cool?
Mm-hmm.
Okay, this question is a little bit tricky. It's not difficult. It's quick if you know what you're looking for. So part C is now asking you for G inverse of 2. And remember what inverse means. Inverse means the points are swapped, okay? So when you're finding G inverse of 2 from a graph of G, what you're looking for this is this. So again, you have G, you have a certain point, X and Y, that becomes Y and X here. Yeah?
Mm-hmm.
So G inverse of 2, G inverse of 2. Oh, look at this. This is the X value on the inverse. That would have been the Y value on the original function G, right?
Mm-hmm.
So what it's asking you is G inverse of 2 is the same thing as, well, what's the X value? What's the X value in G that gives you a Y value of 2? That makes Y value of 2. This is the question you should be asking yourself. Because we don't have a graph of G inverse. So to find that from a graph of G, you need to ask yourself, there's some value of X in G. When I plug that in, I get a Y value of 2. So what X value gives me a Y value of 2? No? So your Y is here, Y value of 2 is here, right? Now the only point that gives me, the only X value that gives me a Y value of 2 is right here. It says
Mm-hmm.
estimate, so you don't have to be super precise. I'm gonna say that's around 0.2, because it looks like it's a fifth of that box. So we're gonna say it's 0.2. Did that make sense?
Mm-hmm.
Okay, what would be, this is easy one. G inverse of 3. Can you tell me what that would be? Same idea. All I did was I replaced 2 with a 3. In other words, what's the X value in G that gives a Y value of 3?
2.
2. Done. Easy peasy. D, estimate the domain of G inverse of X. All right, here's the thing about domains. So you have your F, or you have your G, you have your G inverse. This one has a domain, this one has a range. Domain is going to be in terms of X, range is going to be in terms of Y. The domain of this function in G is the range of this function in G inverse. The range of this in G is the domain of G inverse. So part D is asking you to estimate the domain of G inverse. That is the range of G. Okay? Domain of G inverse is the range of G. So what's the range of G? Approximately. I don't know if these graphs go forever. So on the range, looks like it's -1 is the lowest value. 2, 3, and let's say 3.5 is the maximum value, right? So the domain, sorry, the range of G right now is between -1 and positive 3.5. That means the domain of G inverse will be the exact same thing. The range of one is the domain of the other. Cool? Part E, sketch the graph of G inverse. Remember what an inverse function is. All the points, what happens? What's
There's
an in?
some.
They swapped, yeah, they're swapped. So let's make a table of values for the points that we have right now. And we're just gonna swap them out. So right now we have 0, 1, right? -2, -1. I'm just writing down some of the nice points. 2, 3. I think those are the only whole number points, yeah? So now we're just gonna flip them. Remember, G inverse, this is for G. G inverse, every point is just gonna be flipped upside down. Not upside down, but like X and Y. So now the X are gonna be these values. 1, -1, 3. The Y are gonna be these values. 0, -2, 2. So here you go. 1, 0 is right here. -1, -2 is down here. And then 3, 2 is over here. Mm, that doesn't really help us see the shape. Maybe we use one more point. Looks like that one is 0.5 and 2.5. So it'll become 2.5 and 0.5. So 2.5 and 0.5. Like that. And then you kind of just connect the dots. So that's what the inverse function looks like. Cool? So again, not terribly difficult. Another way to graph the inverse function, actually, if you don't want to plot the points, what if they're not given, you're not given any points, right? That's what they do sometimes. They will just give you something like, hey, here's a function. Can you draw the inverse? And they won't give you any points. So what do you do in that case when no points are given? Inverse, okay, G inverse. Inverse functions are a reflection on the axis y equals x. We talked about vertical reflection, horizontal reflection, and transformations. This is similar, except it's neither vertical nor horizontal. It's a reflection on the axis y equals x. Y equals x is just a straight line that goes through these points. Okay, like that. That's your mirror. So what you do is you kind of just like mirror whatever you have on this. It's not a perfect mirror image, but maybe I'll try it a little bit harder. Maybe it would look something like this, okay? So it's just a mirror image. You just put a reference line here in the center. This is called, this has many names, okay? It's called a 45-degree line. It's called just a reference line. It's called y equals x. It's just a mirror image on that line. So if they don't give you a point, it's not the end of the world. Cool?
Hmm.
All right, that's it for us for today.
Okay, thank you.
See ya.